Artificial intelligence, or AI, is transforming our world. From self-driving cars to personalized medicine, AI is revolutionizing industries and reshaping our lives. At the heart of this AI revolution lies machine learning, a powerful set of techniques that enable computers to learn from data without explicit programming. Machine learning algorithms power a wide range of applications, including image recognition, natural language processing, and predictive analytics. As AI and machine learning continue to advance, we can expect even more transformative applications in the years to come. The rapid growth of AI and machine learning has been fueled by the availability of massive data sets and the development of powerful computing resources. These advancements have made it possible to train complex machine learning models that can achieve human-level performance on a variety of tasks. As a result, AI is becoming increasingly accessible to businesses and individuals alike. This democratization of AI is leading to an explosion of innovation, with new AI-powered applications emerging all the time. The future of AI is bright, and the possibilities are endless. As AI continues to evolve, it has the potential to solve some of the world's most pressing problems, from climate change to disease. However, it's important to remember that AI is a tool, and like any tool, it can be used for good or for evil. It's up to us to ensure that AI is developed and used responsibly, in a way that benefits all of humanity. In the world of AI and machine learning, TensorFlow stands out as a leading open-source platform developed by Google. TensorFlow empowers developers and researchers to build and deploy sophisticated machine learning models, pushing the boundaries of what's possible with AI. TensorFlow's versatility and scalability have made it a popular choice for a wide range of applications, from image classification to natural language processing. One of TensorFlow's key strengths is its ability to run on various hardware platforms, from CPUs and GPUs to specialized AI accelerators like tensor processing units. This flexibility allows developers to optimize their models for speed and efficiency, whether they are training on a single machine or a large-scale distributed cluster. TensorFlow also benefits from a vibrant and active community of developers and researchers worldwide. This community contributes to TensorFlow's growth, provides support, and shares valuable resources, making it easier for newcomers to get started with machine learning. TensorFlow's comprehensive ecosystem includes a wide range of tools and libraries that simplify the process of building, training, and deploying machine learning models. These tools provide high-level abstractions that allow developers to focus on the logic of their models without getting bogged down in low-level implementation details. Whether you're a seasoned machine learning practitioner or just starting your journey, TensorFlow offers a wealth of resources to support your learning and development. TensorFlow's impact on the field of AI and machine learning is undeniable. Its intuitive APIs and flexible architecture have made it a go-to platform for researchers and developers alike, fostering innovation and accelerating progress in the field. TensorFlow's widespread adoption has led to the development of countless applications that are already transforming various industries. In healthcare, TensorFlow is being used to develop cutting-edge applications for medical image analysis, disease diagnosis, and drug discovery. TensorFlow's ability to process and analyze complex medical images, such as X-rays, kinetic scans, and MRIs, is helping doctors make faster and more accurate diagnoses, leading to improved patient outcomes. TensorFlow is also being used to develop personalized medicine approaches, tailoring treatments to individual patients based on their genetic makeup and lifestyle factors. Beyond healthcare, TensorFlow is making its mark in finance, where it is being used to develop sophisticated algorithms for fraud detection, risk assessment, and algorithmic trading. TensorFlow's ability to analyze vast amounts of financial data and identify patterns that would be difficult or impossible for humans to spot makes it an invaluable tool for financial institutions looking to gain a competitive edge. TensorFlow is also being used to develop chatbots and virtual assistants that can provide personalized financial advice and assistance to customers. Before diving into the world of TensorFlow and beginning your journey into the realm of AI, it's essential to prepare your system properly. This involves ensuring your hardware meets the minimum requirements and understanding the software dependencies that TensorFlow relies on. A smooth and efficient development experience hinges on a well-prepared system, so let's ensure you have all the necessary components in place. Firstly, it's crucial to determine the appropriate TensorFlow installation method for your needs. TensorFlow offers a great deal of flexibility in this regard, catering to different operating systems, hardware configurations, and levels of expertise. You can choose to install TensorFlow using the popular package manager pip, opt for a virtual environment with Conda for better dependency management, or build TensorFlow from source for greater control over the installation process. The choice depends on your specific requirements and preferences. Hardware-wise, TensorFlow performs best on systems with ample RAM and a dedicated GPU. While you can run TensorFlow on a standard CPU, leveraging the parallel processing capabilities of a GPU can significantly accelerate the training of complex models, especially those involving deep learning. If you're planning to work with large datasets or resource-intensive models, investing in a GPU will drastically reduce training times and enhance your overall productivity. Lastly, ensure your operating system is compatible with the TensorFlow version you intend to install. TensorFlow supports various operating systems, including Linux, macOS, and Windows. Each operating system may have specific prerequisites or recommended configurations for optimal TensorFlow performance. Once you've ensured your system meets the necessary requirements, the next step is to choose the installation method that best suits your needs. TensorFlow offers several installation options, each with its advantages and considerations. Selecting the most appropriate method can streamline your workflow and ensure a smoother experience. For beginners or those looking for a straightforward installation process, using pip, the package installer for Python, is recommended. Pip simplifies the installation of TensorFlow and its dependencies, automatically resolving and downloading the necessary packages. With a simple command in your terminal or command prompt, you can have TensorFlow up and running in no time. This method is well suited for users primarily focused on utilizing TensorFlow's pre-built models and functionalities. If you require greater control over your development environment or plan to work on multiple projects with potentially conflicting dependencies, installing TensorFlow within a virtual environment using Conda is advisable. Conda is an open-source package management system and environment management system that allows you to create isolated environments for your projects. This isolation prevents conflicts between packages used in different projects and ensures a clean and reproducible development environment. For advanced users who require customization or want to work with the latest TensorFlow features that might not yet be available in pre-built packages, building TensorFlow from source is an option. This method provides the highest level of control over the installation process, allowing you to customize build configurations and optimize TensorFlow for your specific hardware. However, it also requires a deeper understanding of TensorFlow's build system and dependencies. After successfully installing TensorFlow using your chosen method, it's crucial to verify the installation and ensure everything is functioning correctly. This step involves running a simple test script or command to confirm that TensorFlow is accessible and operational. Verifying the installation provides peace of mind and helps identify any potential issues early on. One common way to verify your TensorFlow installation is to run a simple Hello World program. This program typically involves importing the TensorFlow library and printing its version number. If the installation was successful, the program will execute without errors and display the installed TensorFlow version. This verification confirms that TensorFlow is correctly installed and accessible from your Python environment. Another way to verify the installation is to run a basic computation using TensorFlow. This could involve creating a simple TensorFlow constant and using TensorFlow operations to perform a calculation. By executing this code snippet and observing the expected output, you can confirm that TensorFlow's core functionalities are working as intended. This further validates your installation and provides confidence in using TensorFlow for more complex tasks. Furthermore, if you plan to utilize TensorFlow with GPU acceleration, it's essential to verify that TensorFlow can detect and utilize your GPU. TensorFlow provides specific commands and functions to list available GPUs and test their functionality. By running these commands, you can confirm that TensorFlow recognizes your GPU and can leverage its computational power for accelerated training and execution of your models. These verification steps are crucial to ensure that your TensorFlow installation is successful, and that you can start building and experimenting with machine learning models without encountering any unexpected issues. Before we delve into the intricacies of building a linear regression model in TensorFlow, let's take a step back and understand the fundamental concepts behind this powerful statistical technique. Linear regression, at its core, is about establishing a relationship between two or more variables. Imagine you're trying to predict a person's weight based on their height. Intuitively, we know that taller individuals tend to weigh more than shorter individuals. Linear regression allows us to quantify this relationship, enabling us to make predictions about a person's weight given their height. In the world of data science and machine learning, this relationship is represented by a mathematical equation known as a linear equation. This equation typically takes the form of y equals sine mx plus c, where y represents the dependent variable, the variable we want to predict, in this case weight. X represents the independent variable, the variable we use to make the prediction, in this case height. M represents the slope of the line, indicating how much y changes for every unit change in x. And c represents the y-intercept, the value of y when x is 0. The goal of linear regression is to find the values of m and c that best fit our data. This best fit is determined by minimizing the difference between the predicted values of y, based on our linear equation, and the actual values of y in our data set. This difference is typically measured using a metric called the mean squared error, MSE. By finding the values of m and c that minimize the MSE, we obtain the line that best represents the relationship between our variables. Linear regression is a versatile technique with applications in various fields, from economics and finance to healthcare and social sciences. It allows us to make predictions, understand the relationships between variables, and gain insights from our data. In the context of TensorFlow, linear regression serves as a fundamental building block for more complex machine learning models, and provides a gentle introduction to the world of deep learning. Now that we've grasped the essence of linear regression, let's bring this knowledge to life by building our first TensorFlow model. TensorFlow, with its intuitive APIs and flexible architecture, makes it remarkably easy to implement and train machine learning models. We'll start by importing the necessary TensorFlow libraries and creating a simple dataset to work with. This dataset will consist of two arrays, one for our independent variable, let's say the number of hours studied, and another for our dependent variable, let's say exam scores. In this code snippet, we first import the TensorFlow library using the conventional alias TF. We then use NumPy to create two arrays, hours_studied and exam_scores, representing our independent and dependent variables. Next, we define our linear regression model using the layer width signifies that our output is a single value, the predicted exam score, and indicates that our model expects a single input feature, hours studied. With our model defined, we need to compile it, specifying the optimizer and loss function. The optimizer determines how the model's parameters are adjusted during training to minimize the loss function, which quantifies the difference between predicted and actual values. Here, we use the stochastic gradient descent, SGD optimizer, and the mean squared error, MSE loss function. These choices are common starting points for linear regression problems. Compiling the model prepares it for training, the next step in our TensorFlow journey. With our TensorFlow model compiled and ready, it's time to unleash its learning capabilities by training it on our dataset. During training, the model iteratively adjusts its internal parameters to minimize the loss function, effectively learning the relationship between the number of hours studied and exam scores. We use the method, providing our training data, and specifying the number of epochs, iterations over the entire dataset, to train for. In this case, we train for 500 epochs, allowing the model sufficient time to learn the underlying pattern. As the model trains, TensorFlow displays the training progress, showing the loss decreasing over epochs, indicating that the model is improving its predictions. Once the training is complete, we can evaluate the model's performance on unseen data to assess its generalization ability. This evaluation helps us understand how well our model would perform in a real-world scenario where it encounters new data points. We create a new array, representing unseen data points. Using the method, we obtain the model's predictions for these new data points. Finally, we print the predicted scores, allowing us to assess how well our model generalized to unseen data. By following these steps, we've successfully built, trained, and evaluated our first linear regression model in TensorFlow. This simple example provides a glimpse into the power and flexibility of TensorFlow for tackling machine learning problems. While linear regression serves as a solid foundation in machine learning, real-world data often exhibits complex patterns that cannot be captured by simple linear relationships. Enter convolutional neural networks, or CNNs, a class of deep learning models specifically designed to excel at processing data with a grid-like structure such as images. CNNs have revolutionized the field of computer vision, achieving human-level performance on tasks like image classification, object detection, and image segmentation. Unlike traditional neural networks that treat each input feature independently, CNNs leverage the spatial relationships between pixels in an image. They employ specialized layers called convolutional layers that scan the image using small filters, detecting local patterns like edges, corners, and textures. These filters are then slid across the entire image, creating feature maps that highlight the presence and location of these patterns. Another key component of CNNs is pooling layers, which downsample the feature maps, reducing their dimensionality while retaining essential information. This downsampling not only reduces computational complexity, but also makes the model more robust to variations in the position and scale of objects within the image. Through a combination of convolutional and pooling layers, CNNs learn a hierarchy of features, from simple edges and textures in the early layers to complex object parts and representations in the deeper layers. This hierarchical feature learning enables CNNs to effectively capture the intricate patterns present in images, leading to remarkable performance in various computer vision tasks. Building a CNN in TensorFlow is like assembling a powerful engine for image recognition. We'll use TensorFlow's Keras API, a high-level interface for building and training deep learning models, to construct our CNN architecture. Our goal is to create a CNN capable of classifying handwritten digits from the famous MNIST dataset, a classic benchmark problem in machine learning. We begin by importing the necessary layers and models from. We then create a sequential model, which allows us to stack layers one after the other. The first layer is our convolutional layer with 32 filters, each of size 3 by 3. This specifies the rectified linear unit activation function, which introduces nonlinearity into the model. It defines the shape of our input images, 28 x 28 pixels, grayscale. We then add a layer with a pool size of 2 by 2, downsampling the feature maps. This pattern of convolutional and pooling layers is repeated twice, gradually increasing the number of filters to capture more complex features. Finally, we flatten the output from the convolutional layers using and feed it into 2 fully connected layers for classification. The last layer has 10 outputs corresponding to the 10 digits with a softmax activation function to produce probability scores for each class. With our CNN architecture meticulously crafted, we're ready to train it on the MNIST dataset and witness its ability to recognize handwritten digits. Training a CNN involves feeding it numerous examples of handwritten digits along with their corresponding labels, allowing the model to learn the patterns that distinguish each digit. We compile our model using the Atom optimizer, a popular choice for training deep learning models, and the sparse categorical cross-entropy loss function, suitable for multi-class classification problems. We then load the MNIST dataset from, reshape the data to match our input shape, and normalize the pixel values between 0 and 1. We initiate the training process using providing the training data, specifying the number of epochs, and monitoring the accuracy metric. During training, the model iteratively adjusts its parameters to minimize the loss function, effectively learning to classify the digits. Once trained, we can unleash our CNN on new, unseen handwritten digits, and it will predict the digit with impressive accuracy, showcasing the power of CNNs in image recognition tasks. This journey through building and training a CNN for handwritten digit recognition provides a glimpse into the exciting world of deep learning with TensorFlow. As we delve deeper into TensorFlow's capabilities, we'll uncover even more advanced techniques and applications, pushing the boundaries of what's possible with AI. The healthcare industry, with its vast amounts of data and complex challenges, has emerged as a fertile ground for TensorFlow's transformative capabilities. TensorFlow's prowess in image recognition, pattern detection, and data analysis is revolutionizing medical imaging and diagnostics, leading to faster, more accurate diagnoses, personalized treatment plans, and improved patient outcomes. One of TensorFlow's most significant contributions to healthcare lies in its ability to analyze medical images with remarkable accuracy. CNNs, trained on massive datasets of labeled medical images, can detect subtle anomalies in X-rays, kinetic scans, and MRIs that might escape even the most experienced human eye. This early and accurate detection of diseases like cancer, pneumonia, and diabetic retinopathy allows for timely intervention and improves the chances of successful treatment. Beyond image analysis, TensorFlow is also being used to develop predictive models that can identify individuals at risk of developing certain diseases. By analyzing electronic health records, genetic information, and lifestyle factors, TensorFlow can help healthcare providers identify high-risk patients and recommend preventive measures or early screenings. This proactive approach to healthcare can potentially save lives and reduce healthcare costs in the long run. TensorFlow's impact on healthcare extends beyond diagnostics and risk prediction. Researchers are also leveraging TensorFlow to develop personalized medicine approaches, tailoring treatments to individual patients based on their unique genetic makeup, lifestyle, and environmental factors. This personalized approach to medicine aims to optimize treatment efficacy while minimizing side effects, ushering in a new era of precision medicine. Section 2. TensorFlow in Finance, Powering Algorithmic Trading and Risk Management. The world of finance, characterized by its data-driven nature and relentless pursuit of profit, has embraced TensorFlow as a powerful tool for gaining a competitive edge. TensorFlow's ability to analyze vast amounts of financial data, identify complex patterns, and make predictions with remarkable accuracy has revolutionized algorithmic trading, risk management, and fraud detection in the financial industry. Algorithmic trading, once the exclusive domain of hedge funds and institutional investors, has become increasingly accessible to individual traders thanks to platforms powered by TensorFlow. TensorFlow-based algorithms can analyze market data in real time, identify trading opportunities, and execute trades automatically based on predefined rules and risk parameters. This automation allows traders to react to market movements with lightning speed, capitalizing on fleeting opportunities that would be impossible for humans to exploit manually. Beyond algorithmic trading, TensorFlow is also transforming risk management in the financial industry. TensorFlow's ability to analyze historical data, identify patterns of fraudulent activity, and assess creditworthiness makes it an invaluable tool for banks, insurance companies, and other financial institutions. By leveraging TensorFlow's predictive capabilities, these institutions can make more informed lending decisions, detect and prevent fraudulent transactions, and manage risk more effectively. TensorFlow's impact on the financial industry extends beyond trading and risk management. Chatbots and virtual assistants powered by TensorFlow are being deployed by banks and financial institutions to provide personalized financial advice, answer customer queries, and streamline customer service operations. These AI-powered assistants can handle a high volume of inquiries simultaneously, providing 24/7 support and improving customer satisfaction. Section 3. TensorFlow in Other Industries, Expanding Horizons Across Diverse Domains. While TensorFlow's impact on healthcare and finance is undeniable, its reach extends far beyond these industries, transforming diverse sectors, from manufacturing and retail to transportation and entertainment. TensorFlow's versatility, ease of use, and extensive community support have made it the go-to platform for businesses and organizations of all sizes looking to harness the power of AI. In manufacturing, TensorFlow is being used to optimize production processes, improve quality control, and predict equipment failures. Sensors embedded in machinery and equipment generate a constant stream of data, which TensorFlow can analyze to identify patterns and anomalies, allowing manufacturers to optimize machine settings, schedule maintenance proactively, and minimize downtime. This data-driven approach to manufacturing, often referred to as Industry 4.0, is transforming the way goods are produced, leading to increased efficiency, reduced costs, and improved product quality. Retailers are also leveraging TensorFlow to enhance the customer experience, personalize marketing campaigns, and optimize inventory management. By analyzing customer data, purchase history, and browsing behavior, TensorFlow can help retailers recommend products that align with individual preferences, personalize marketing messages, and optimize pricing strategies. TensorFlow-powered chatbots and virtual assistants are also being deployed to provide instant customer support, answer product-related queries, and guide customers through the purchasing process. The transportation industry is undergoing a significant transformation with the advent of autonomous vehicles, and TensorFlow is playing a crucial role in this revolution. Self-driving cars rely heavily on computer vision to perceive their surroundings, make driving decisions, and navigate safely. TensorFlow's image recognition capabilities, particularly its ability to detect and classify objects in real time, make it an essential component of the software stack that powers autonomous vehicles. Section 4. Expanding the reach of TensorFlow. TensorFlow's impact on entertainment is equally profound. Streaming services like Netflix and Spotify use TensorFlow to power their recommendation engines, suggesting movies, TV shows, and music based on user preferences and viewing history. TensorFlow is also being used to create realistic special effects in movies and video games, generate personalized content, and even compose music. These examples merely scratch the surface of TensorFlow's vast potential. As TensorFlow continues to evolve and mature, we can expect even more innovative applications to emerge, transforming industries and reshaping our world in profound ways. Its accessibility, versatility, and the support of a vibrant community ensure that TensorFlow will remain at the forefront of the AI revolution, empowering individuals and organizations alike to unlock the transformative power of machine learning. The democratization of AI, driven in no small part by platforms like TensorFlow, is leading to an explosion of creativity and innovation across all sectors. From healthcare to finance, manufacturing to entertainment, TensorFlow is empowering individuals and organizations to tackle complex challenges, automate tasks, and create entirely new possibilities. As we venture further into the age of AI, TensorFlow will undoubtedly continue to play a pivotal role in shaping the future and unlocking a world of unprecedented opportunities. Having explored the vast capabilities of TensorFlow across various industries, it's essential to delve into the best practices that can significantly enhance the performance and efficiency of your TensorFlow models. These practices encompass a range of techniques and considerations that span data preparation, model design, and hardware utilization, ensuring that you extract the maximum value from your TensorFlow projects. One of the fundamental pillars of optimal TensorFlow performance lies in efficient data handling. TensorFlow thrives on data, and how you prepare and feed data to your models can significantly impact training speed and accuracy. Start by ensuring your datasets are clean, well-structured, and free of inconsistencies or missing values. Consider using TensorFlow's data input pipelines, which allow you to load, pre-process, and feed data to your models efficiently, especially when dealing with large datasets that might not fit entirely in memory. Choosing the right model architecture for your specific task is another crucial aspect of TensorFlow optimization. While TensorFlow offers a vast library of pre-built models and architectures, selecting the most appropriate one for your specific problem can significantly impact performance. Consider the complexity of your task, the size of your dataset, and the desired accuracy level when making this decision. Experimenting with different architectures and hyperparameters, a process known as hyperparameter tuning, can help you find the optimal balance between model complexity and performance. Hardware acceleration plays a pivotal role in unlocking the full potential of TensorFlow, especially when training complex models on large datasets. Leveraging the parallel processing power of GPUs or specialized hardware like TPUs can significantly reduce training times, allowing you to iterate faster and explore a wider range of model architectures. TensorFlow provides seamless integration with GPUs and TPUs, making it easy to harness the power of hardware acceleration. As we venture further into the age of AI, powered by platforms like TensorFlow, it's imperative to address the ethical considerations surrounding its development and deployment. AI systems are increasingly making decisions that impact our lives, from loan approvals to medical diagnoses, and it's crucial to ensure that these systems are fair, unbiased, and transparent in their operations. One of the primary ethical concerns in AI is bias. AI systems are trained on data, and if that data reflects existing societal biases, the resulting models may perpetuate or even amplify those biases. For instance, a facial recognition system trained on a dataset predominantly composed of light-skinned faces might perform poorly on darker-skinned faces, leading to unfair or discriminatory outcomes. It's essential to carefully curate and evaluate training datasets for potential biases, ensuring they are diverse and representative of the populations the AI system is intended to serve. Transparency and explainability are equally important in ethical AI. As AI systems become more complex, it can be challenging to understand the reasoning behind their decisions. This lack of transparency can erode trust in AI systems, especially in high-stakes domains like healthcare or finance. Researchers are actively developing techniques to make AI models more interpretable, allowing humans to understand the factors that influence their decisions. This increased transparency can help ensure that AI systems are used responsibly and ethically. Privacy is another critical concern in the age of AI. AI systems often require access to vast amounts of personal data, and it's crucial to handle this data responsibly, protecting user privacy and complying with relevant regulations. Techniques like differential privacy and federated learning are emerging as ways to train AI models on sensitive data without compromising individual privacy. The field of AI, with TensorFlow at its forefront, is continuously evolving, pushing the boundaries of what's possible and transforming industries at an unprecedented pace. As we look ahead, several trends and advancements are poised to shape the future of TensorFlow and AI, unlocking even greater potential and ushering in a new era of intelligent applications. One of the most significant trends in AI is the rise of edge computing, where AI processing is moving closer to the source of data, such as smartphones, sensors, and other devices at the edge of the network. TensorFlow Lite, Google's lightweight version of TensorFlow designed for mobile and embedded devices, is enabling developers to deploy AI models on edge devices, enabling real-time decision-making and reducing reliance on cloud connectivity. This shift towards edge AI is opening up new possibilities for applications in areas like healthcare, manufacturing, and transportation, where real-time responsiveness is critical. Quantum computing, a revolutionary computing paradigm that harnesses the principles of quantum mechanics, holds immense promise for accelerating AI workloads. TensorFlow Quantum, an open-source library for quantum machine learning, is paving the way for developers to explore the potential of quantum computing for AI applications. While quantum computing is still in its early stages of development, it has the potential to revolutionize fields like drug discovery, materials science, and financial modeling, solving problems that are currently intractable for classical computers. The democratization of AI, driven by platforms like TensorFlow, is another significant trend shaping the future of the field. With its intuitive APIs, extensive documentation, and vibrant community support, TensorFlow is making AI accessible to a wider audience, including developers, researchers, and businesses of all sizes. This increased accessibility is fostering innovation and driving the development of new AI-powered applications across various domains. As we conclude our exploration of mastering TensorFlow, it's evident that we've only scratched the surface of its vast capabilities and the transformative potential of AI. TensorFlow, with its intuitive APIs, flexible architecture, and extensive ecosystem, has democratized access to AI, empowering individuals and organizations alike to harness its power to solve complex problems, automate tasks, and create innovative solutions across various industries. From revolutionizing healthcare with more accurate diagnoses and personalized treatments to transforming finance with algorithmic trading and risk management, TensorFlow is leaving its mark on countless domains. Its ability to analyze vast amounts of data, identify intricate patterns, and make predictions with remarkable accuracy is driving the development of intelligent applications that are changing the way we live, work, and interact with the world around us. The journey into the world of TensorFlow and AI is both exciting and challenging. As you delve deeper into its intricacies, remember to approach AI development responsibly, considering the ethical implications and striving to create systems that are fair, unbiased, and beneficial to society. Embrace the power of TensorFlow, unleash your creativity, and embark on a rewarding journey of exploration and innovation in the ever-evolving landscape of AI. Throughout this comprehensive guide, we've embarked on an illuminating journey into the world of TensorFlow, Google's open-source powerhouse for machine learning and deep learning. We've demystified the complexities of AI, making it accessible and understandable, empowering you to harness its transformative capabilities. From setting up TensorFlow on your machine to building sophisticated CNNs for image recognition, we've covered a wide spectrum of topics, equipping you with the knowledge and tools to embark on your own AI adventures. Our journey began with a gentle introduction to the fundamentals of AI and machine learning, laying the groundwork for understanding the core concepts that underpin TensorFlow's power. We delved into the practicalities of setting up TensorFlow, ensuring a smooth and efficient development experience. Through hands-on examples, we explored the intricacies of building, training, and evaluating machine learning models, from simple linear regressions to complex CNNs, demystifying the process and empowering you to create your own intelligent applications. But mastering TensorFlow extends beyond mere technical proficiency. We've also explored the ethical considerations surrounding AI, emphasizing the importance of responsible development and deployment. As AI systems increasingly influence our lives, it's crucial to ensure fairness, transparency, and accountability in their design and implementation. By embracing ethical AI practices, we can harness the transformative power of TensorFlow while safeguarding against potential pitfalls. As we stand at the cusp of a new era defined by AI, TensorFlow stands as a beacon of innovation, empowering us to shape the future and unlock unprecedented possibilities. The rapid pace of advancements in AI, coupled with TensorFlow's versatility and accessibility, ensures that the journey we've embarked upon is just the beginning of an exciting and transformative adventure. The future of AI is brimming with potential, and TensorFlow is at the forefront of this revolution. From the rise of edge computing, bringing AI processing closer to the source of data, to the exploration of quantum computing, pushing the boundaries of computational power, TensorFlow is constantly evolving to embrace the latest advancements and empower developers to create cutting-edge AI applications. The democratization of AI, fueled by platforms like TensorFlow, is another exciting trend shaping the future of the field. With its intuitive APIs, extensive documentation, and vibrant community support, TensorFlow is making AI accessible to a wider audience than ever before. This increased accessibility is fostering innovation, driving the development of new AI-powered applications across various domains, and empowering individuals from all walks of life to participate in the AI revolution. As we conclude this comprehensive guide to mastering TensorFlow, remember that learning is a continuous journey, and the world of AI is constantly evolving. Embrace the challenge, stay curious, and never stop exploring the vast possibilities that TensorFlow and AI offer. The knowledge and skills you've gained from this guide provide a solid foundation for further exploration and experimentation. The TensorFlow community is a vibrant and supportive one, with a wealth of resources available to help you on your journey. Explore the official TensorFlow website, delve into the extensive documentation, join online forums, and connect with fellow enthusiasts to share knowledge, seek guidance, and stay abreast of the latest advancements. As you continue your TensorFlow journey, remember to challenge yourself, experiment with new ideas, and never be afraid to push the boundaries of what's possible. The world of AI is your oyster, and with TensorFlow as your guide, you have the power to create innovative solutions, solve complex problems, and shape the future in profound ways. The future of AI is brimming with possibilities, and with TensorFlow at your fingertips, you are well equipped to embark on this exciting journey of discovery, innovation, and transformation. Embrace the challenge, unleash your creativity, and let TensorFlow be your guide as you explore the limitless potential of AI.